I'm going to click start recording too. All right, so today we're looking at partial fractions and what a partial fraction is, how to create partial fractions. We're going to do some review. We're going to talk about some words that y'all have done a lot of times in the past, but chances are they haven't been used in a while. So we'll see how that goes. Just kind of make it up as we go, like we always do. Objectives: recognize what a partial fraction decomposition is, and find partial fraction decompositions of rational expressions. In this section, you're going to learn how to write a rational expression as the sum of two or more simpler rational expressions. For example, this is a rational expression. Do y'all remember what a rational expression is? What makes an expression a rational fraction? A rational expression. It's a ratio of expressions. Okay, a ratio is another word for fraction. So is this a fraction? Is there a polynomial on top? Is there a polynomial on the bottom? That's a rational expression. This fraction can be rewritten as 2 over x minus 3 plus negative 1 over x plus 2. That's what we're going to be doing as far as what partial fractions are. We're actually going to work this problem here in just a little bit. How did we turn x plus 7 over x squared minus 6 minus x squared minus x minus 6 into this? Each one of these is a partial fraction, because if I add this fraction and this fraction together, I get this fraction. Okay, so a partial fraction is a part of a fraction. That's what we're doing. Okay. This is very important in calculus. We don't touch a whole lot of it on this in pre-cal, but it'll come back in calculus. Each fraction on the right side of the equation is a partial fraction, and together they make up the partial fraction decomposition of the left side. Okay, so time for some review here. I want to add those together. Does that look familiar? Weren't these two fractions the exact same ones on the previous page? I want to add them together. How do you add fractions together? What must be true? Common denominator. Common denominator. These denominators aren't the same. How do I make them the same? Okay, yeah. So if the fraction on the left has an x minus 3 in the denominator, the one on the right must also have an x minus 3 in the bottom, right? Well, I can't just come over here and write it, but I can multiply this fraction by 1, correct? Okay. So what I'll do is I'll multiply both fractions by a 1. The one on the left needs an x plus 2, so I'm going to multiply it by x plus 2 over x plus 2. The one on the right, I'll multiply by x minus 3 over x minus 3. Do I now have a common denominator? Yes. Okay. So let's look at this guy here. Distribute the 2, and you get 2x plus 4. Good. Divided by, FOIL the bottom. X squared what? Minus x minus 6. Minus numerator, x minus 3. Denominator better be the same, right? That's why we got a common denominator. Because I have a common denominator, I combine these. And this is where you have to be really careful. I'm subtracting that x minus 3. Okay? So the best way to rewrite this would be 2x plus 4 minus x minus 3 over x squared minus x minus 6. Combine like terms on the top, what do you get? 2x minus x is x. Nice. Four minus negative 3 plus 7 over x squared minus x, which is what we knew it was going to be because that's the problem we started with. Okay? All right. Questions on that? Okay? Here's some terms you might not have seen in a while. What's a proper fraction? What's an improper fraction? What makes a fraction proper or improper? Okay. So is 1/5 proper or improper? Why? Okay, because it's less than a whole. Do it. Okay. It's proper because this number is the bigger number, right? If the bottom number is bigger than the top, that makes it proper, right? When was the last time you talked about proper and improper fractions? Can you? 6th grade. It's been a long time. Okay. So 11/6 would be improper. 3/2, improper. 5/8. Okay. And the reason I bring that up is because it's important when we're dealing with rational expressions as well. Because a rational expression can also be proper or improper. It says a rational expression is proper if the degree of the numerator is, the degree of the denominator is greater than the degree of the numerator. A rational expression is improper if the degree of the numerator is greater than or equal to the degree of the denominator. So it's the same concept, but we're looking at the degrees. And there's one difference here. When we're talking about regular fractions, we don't talk about the numbers being the same. Okay? The first one, I have x squared plus x minus 8 divided by 2x squared minus 11x plus 14. What's the degree of the numerator? 2. Degree of the denominator? 2. Okay? And how do those numbers compare? Same, so if this is an improper fraction. Second example, the degree of the bottom, 2. Degree of the top, 1. So this is proper because the degree of the bottom is larger than the degree of the top. And the one on the bottom, the degree of the numerator, 3. Degree of the denominator, 2. So it's improper. All right. That's it for the review of stuff we've talked about in the past or prior years before me. Okay. Here are the steps for decomposing a rational expression into partial fractions. Number 1, if your fraction is improper, you must first do division, which is going to be longhand division. Okay, we will not look at an example of that today. Once you have that done, then you'll look at just the fraction part. Okay? Step number 2, factor the denominator. Very, very important. And you must factor the denominator completely, and it must be correct. These are going to be the pieces of your partial fraction. Step number 3, if you have linear factors, for every linear factor, you will place an A above, or a number or a letter above each one. A1, A2, A3, or maybe A, B, C, D, and so on. If you end up with a quadratic factor that does not factor, instead of putting just an A above it, you would actually put like a BX plus C, or DX plus E, or FX plus G. We will not do one of those today. We're going to stick with linear factors today. The following examples demonstrate algebraic techniques for determining the constants in the numerators of partial fractions. Note that the techniques vary slightly depending on the type of factors of the denominator, linear or quadratic. Again, we won't be doing quadratics today. We will do both a distinct, what's distinct mean? Okay, each one is different. We'll talk about distinct and repeated linear factors. We'll actually do one of each of those. Time permitting, of course. All right, so here we go. Write the partial fraction decomposition of, does this guy look familiar? It's the exact same problem? Okay, so I'm going to show you the steps to get to that final answer that they got to a while ago. Okay. Step number 1, looking back on the notes, said divide if improper. Is that improper? So we don't need to do it. Step number 2, factor the denominator. The denominator is x squared minus x minus 6. What does that factor into? X minus 3, x plus 2. Okay, y'all good with that? Okay, yeah, two numbers that multiply to get negative 6. That would be negative 3 and 2. But when you add those two numbers together, you get negative 1, which is b. So negative 3 and 2. All right? Okay. Are those linear factors? Is x minus 3 a line? Yes. Is x plus 2 a line? Yes. Are they distinct? Each line is different, right? So I have two distinct linear factors. Okay? Next, I'm going to write the form of a decomposition. I'll write that down. Write the form of the decomposition. I'm starting with my rational expression, x plus 7 divided by x squared minus x minus 6. I'm going to decompose that. How many factors did I get? 2. So I'm going to decompose this into 2 pieces. Each factor represents a denominator. So I'll have a denominator of x minus 3 plus I'll have a denominator of x plus 2. Y'all good with that? The thing is, I don't know what my numerators are going to be. They might be the same, but they might not be. Okay? So since I don't know what they are, I'll just call one of them A and one of them B. Questions on that? Okay? Next thing I want to do is I want to clean this up. I want to clean this up by getting rid of all the fractions. How can you clear fractions? Second plus 712. Reset the calculator. Yes. Okay. How do you clear fractions? Okay, multiply by common denominator. If I multiply every term by the common denominator, it's going to be cleared up, right? What is the common denominator? This is the common denominator. This is the common denominator, right? Those are the same, correct? Okay, so I'm going to multiply this side by x squared minus x minus 6. X squared minus x minus 6. When I multiply the left side by x squared minus x minus 6, what just happened? This canceled this, correct? Okay, what's left? Okay. If I multiply this side by the common denominator, but instead of writing x squared minus x minus 6, I'm going to write it in the factored form. I'm multiplying this side by x minus 3 times x plus 2. Both terms are multiplied by that, correct? If I multiply this first term by x minus 3 times x plus 2, what happens? It cancels the bottom because what gets canceled? The x minus 3 cancels, so what's left? Okay, but it's still an a there, correct? So I have a times x plus 2 plus second term. Okay. Who's totally lost? Are you? You're not? Why? Why are you totally lost?
I mean, I get it. I just don't know. It's not processing. Yeah. You have to do like a.
Oh yeah. Well, this takes practice. To me, they become puzzles, especially if we get into the real ugly ones
Right.
that we'll use matrices to solve. Okay. Okay. This is called my basic equation. This equation is true. Always. Okay? I don't care what x value you give me. This is true. Y'all good with that? This equation is true for all x values. So what problem do we have up here? If x can be anything, what's our problem? What do we not know? We don't know a and b. That's the problem. Right? Did you say that? Okay. Say it louder. Okay. Well, he heard you and he relayed the message to me. Okay. I don't even think Gabe heard you. Okay. All right. So if x can be anything, can you think of any values that we could choose for x that might, like, I don't know, make a go away or make b go away?
Oh, minus 2 plus 2 is 0.
So if x is negative 2, what's going to happen? A is gone. Well, if a is gone, can't we find out what b is? Okay. So your suggestion is we're going to let x equal negative 2. To solve for b. All right? So I'm going to take that equation, and everywhere there's an x, I'm going to change it to a negative 2. So I get negative 2 plus 7 equals a times negative 2 plus 2. Yes, I'm doing extra writing, but I'm showing you what's happening here. Plus b times negative 2 minus 3. Is everybody good with that? Looks pretty simple now, right? Negative 2 plus 7?
Oh.
5 equals a times negative 2 plus 2 plus b times negative 5. Okay, well, let's clean that up. 5 equals a times 0, gone. B times negative 5, negative 5b. What's b? Right? Divide both sides by negative 5. B is negative 1. Yay. Do what? Yeah, but you're going to need an x value. Right?
X is 3.
What do you mean, Tanya?
Oh, that like you would just do like you would be like x would be 3 now.
Okay, let x equal 3. Perfect. Let x equal 3. Going back up to my basic equation, that gives me 3 plus 7 equals a times 3 plus 2 plus b times 3 minus 3. We've taken this problem down to like what, 6th grade algebra problem now, right? You were doing algebra in 2nd grade. Yes, you were. It looked like this. What goes in the box? Right, that's algebra. Congratulations. Okay, equals
6a. Or, sorry, 5a.
a times 5 plus b times 0. So 10 equals 5a. A is 2. Now that I've identified both a and b, I can write down my partial fraction equation. So what was it? X plus 6? No. X plus 7 over x squared minus x minus 6 equals, this was x minus 3 minus plus, this was x plus 2. A is 2, B is, and we're done. That's the answer. Isn't that what we said the answer would be at the very beginning? Those were the two fractions that we added together by getting a common denominator, and we got this. Okay? So all partial fractions are doing is showing you how to decompose that fraction into the smaller fractions that made that new fraction. Okay? Questions on that? Okay? At this point, if you wanted to, you could use your graphing technology, your calculator, or maybe Desmos, and maybe put this thing exactly like that into y1. And if you took this guy right here and put it into y2, and if you graphed it, what would you see? You would see one graph drawn, and then the other graph would be right on top of it, if it was right. Okay? Yes. So like if you're test and you want to verify your answer, good strategy. It'll help you get a grade higher than a 10 on a test.
That's what I said.
Did it work out? Huh? Did you type it right?
Why just
Wait. Nope, I swear I did wrong.
wait, what did I do wrong?
You got to type this whole thing in.
Oh,
I accidentally put plus instead of minus 3 on the bottom. Now,
Okay.
let's see.
Did it work that time? Okay.
cool design. Right. Weird stuff.
Write what down? Oh, how to check it?
What I got though. That's even cooler.
X squared minus, you didn't write down the first equation's wrong, sir. It's x plus 7 over x squared minus x plus.
This is too long.
Okay. Just check.
I hope so. Or did something go wrong?
All right, moving on. The procedure used to solve for the constants in that example, they work well when the factors are linear. However, when the denominator contains irreducible quadratic factors, we're going to use a lot of different procedures. We're going to look at systems of equations. We're going to look at matrices. Lots of different ways to solve it. Moving on. Guidelines for solving the basic equation. This is what we did a while ago. If we have linear factors, this is all we're working on today are linear factors. Number 1, substitute the zeros of the distinct linear factors into the basic equation. Is that what y'all did? We substituted in zeros, made the a go away, substituted another 0, made the b go away. Good. For repeated linear factors, you're going to use the coefficients determined in step 1 to rewrite the basic equation, then substitute for other convenient values of x and solve for the remaining coefficients. Keep in mind, if you start with an improper fraction, you must first reduce, you must divide before moving on. Let's do one more. Write the partial fraction decomposition of 6x over x squared minus 12x plus 36. Is it proper or improper? Proper. So we don't have to divide. Okay, what do we do next? Okay, factor the denominator. X squared minus 12x plus 36 factors into x minus 6 and x minus 6. Are they distinct? No, they're the same, right? Okay. But we still have to have, because it's still two factors, we're still going to have two denominators. So this factors into x minus 6 squared. Again, it is two factors. We must have two fractions. However, the denominators can't be the same. Well, how's that going to work? Okay, so this is where we're going to kind of get creative. All right, next step is form the decomposition. So 6x over x squared minus 12x plus 36 equals, one linear factor is x minus 6 plus the other linear factor is x minus 6, but I just told you we can't use the same thing twice. Okay? So what we do in this case is you count up with the exponents. Okay? This is x minus 6 to the first power. This one's going to be x minus 6 to the second power. They're now different. Okay? Do you agree that those are different denominators? Okay. Even though x minus 6 squared is a quadratic, it's not an irreducible quadratic. It's a quadratic that reduces to x minus 6 times x minus 6. Okay? So we're still going to treat it as though this is a linear factor. I know it's confusing. If we started with some kind of a denominator that factored to x minus 6 cubed, we would have actually gone on and wrote plus something over x minus 6 cubed. Each denominator has to be different. Okay? What are my numerators? What's my numerator for the first one? A. What's the numerator for the second one? B. Because they're still linear factors. Okay? Max, and whose glasses are those? Okay. Are they really? Okay. Oh, yeah? Okay. All right. What are we going to do next? Multiply both sides by common denominator. Okay? Good. Move this thing real quick. Whoa, hello. Let's not do that. All right. Common denominator is this, right? Common denominator is this. So I'm going to multiply the left side by x squared minus 12x plus 36, which makes the left side 6x equals. Multiply the right side by Is that better? I brought it up for you. X minus 6 squared. Okay. If I multiply the first fraction by x minus 6 squared, what's left? A times x minus 6. Yeah, you've already distributed it, but yes. If I multiply the second term by x minus 6 squared, I get B. Go ahead. Because the common denominator is x minus 6 squared. That is both denominators. This one has both of them. This one only has one of them. But both of these go into that evenly. Do what? Oh, finding B is simple. You tell me how to find B. What do you want x to be to find B? There you go. Okay. So let x equal 6 to find B. So that gives us 6 times 6 equals A times 6 minus 6 plus B. 36 equals A times 0 plus B. What's B? Yay. Question is, how do we find A? Okay, then what? Now I've got an X and an A that I still don't know. Why 0? Put 1 or something? Guys, y'all are both right. Okay, because we know that because we know that B is 36, and we know that this equation is true for all x, we can choose any x we want, but don't choose 6. Choose any value for x that you want. In fact, if every one of you chose a different letter for x, different number for x, as long as b is 36, I guarantee we will all get the same, well, assuming you did the math right, we would all get the same value for a. Okay? You wanted to do 1, do 1. Okay, your x is 1 and your b is 36. Okay? Go around. Okay, so we know that b is 36. And we know that this is true for all x. So we can choose any x that we want. Okay. I'm a simple man. I want x to be 0. Because to me, that's going to be less math. Right? But you can choose, again, any number that you want. Go back to your basic equation and plug it in. So mine's going to be 6 times 0 equals a times 0 minus 6 plus 36. 6 times 0 is 0 equals a times negative 6 plus 36. Subtract 36 from both sides. What's a? Zane, did you finish it with 1? And you got 6? Okay.
Will the number just automatically be the number you can't use?
Do what?
Will the number just automatically be the number you can't use?
Which number?
Like you said, you couldn't use 6 and I answered 6.
Yeah. Yeah, if I was trying to solve, if I plugged in a 36 here and a 0, I'm sorry, a 6 here, it's
I think he was meaning like is the number we can't use always going to be the answer. Like,
oh, no. It just happened that way. Yeah. But we do know with this basic equation, this is true for all x values, so I don't care what x is. We choose a convenient one to solve for a or b, and then choose something else to find the other variables. So let's write our final answer. 6x over is equal to a, which is 6 over plus 36 over okay, and that is the partial fraction decomposition of what we started with. Okay. Thoughts? Huh? Was it hard?
no, it takes a lot.
Yeah. You can, yeah.